Now you can start.
So good morning to all. Cryptocurrency is something everyone wants to talk about, but no one really knows how they work. So today I'm going to discuss some points regarding cryptocurrency. So since man is the world, cryptocurrency has played a very important role. Cryptocurrency has played a very important part of our life. So in caveman era, they used the barter system. Barter system involves goods and services in exchange among each other. Suppose we have a situation where a caveman is exchanging 5 apples and getting oranges in return. So barter system felt out of use because it had some flaws. It has some flaws like having people's requirement coincide. For example, say you have 5 apples and friend have 5 oranges. So you want some of his oranges. So now until and unless your friend has a requirement for the apple that you own, he will not be ready to make an exchange for it. This is how people's requirements need to coincide. And there was no common measure of value. Now, since there is no common measure of value in terms of which a value of a commodity can be expressed, there is a problem when you have to decide how many apples you are ready to trade for one orange or for a mango. So, and the third one is not all goods can be divided or subdivided. Like a live animal, we can't divide live animal into subunits. And also the good cannot be transported easily. So after the realization, the barter system didn't work very well. Currency has gone through some iterations. So in 110 BC, an official currency was minted. In 1250 AD, gold, platinum florins were introduced. Whereas from 1680 to 1980 and also till now, paper currency gained widespread popularity. So the modern currency came into the picture after the paper currency came. So modern currency includes paper currency and coins, credit cards and digital wallets like GPay, PhonePe, Amazon Pay, and so on. So all of these were controlled by the banks and governments. This means that there was a centralized regulatory authority that limited how credit card and paper currency works. So all these paper currencies and digital wallets was controlled by the banks, which we call it as centralized system. So now imagine the scenario of doing an online transaction. The two friends are planning to go for the trip and they thought of booking online tickets from a site that offered discount to the first 10 visitors on that day. So while making their respective bookings, the B transactions got failed and he missed the offer. And on the other hand, A paid his shares quickly and easily and became the lucky draw winner. So B was surprised and asked A how he could make the transactions when B himself could not. To which A replied, "It's simple. I just use the Bitcoin, a type of cryptocurrency." So the question here comes is, what is cryptocurrency? So cryptocurrency is a digital or the virtual currency that makes on blockchain technology and designed to work as a medium of exchange online to buy goods and services and make payments. So it's similar to the other online payments. So what makes it so different? So cryptocurrency is a decentralized and free from any third-party interference, which means it is not issued by any government or central authority, unlike other systems that banks or government also handling. That's why cryptocurrency transactions never fail. So there can be many reasons why these transactions got failed, because as he was using modern technology or modern banking, so there might be a technical issue at the bank. The users' accounts were hacked. It may be possibility that the account were hacked or the transfer limit for the account were exceeded. Whereas all these problems of the modern banking was removed by the cryptocurrency, that there is no central point of failure, the users' accounts cannot be hacked, and there was no transfer limit for the account. So what makes cryptocurrency so special?
Wait. Yeah, wait. Yeah, go back and yeah. Any questions to all of you till now? Is it clear? She is clear actually. I'm feeling that everyone is understood. But even then, one small gap. Any one of you? Any questions? Okay, you can go ahead.
So what makes cryptocurrency so special? So first, as we all know, if we are doing any online transaction, there is little cost which is debited from our account. So here there is also some cost, but it is very much little that it is like no cost transactions. Here we are having 24/7 access to money, similar to model banking. But in model banking, many times we suffer from the network, the technical issue from the bank that server is down. But here, in this case, in cryptocurrency, this is not an issue. No limits on purchase and withdrawals. In modern banking, there is always limit. Like in GPay, we have limit of 20,000, but here we are not having any limit. Freedom for anyone to use. Anyone can use this cryptocurrency. Just we need an app to download it. Then international transactions are faster. So as we know, if we will do normal transaction, it takes more than 2 to 3 hours to get complete. But in the cryptocurrency, it just takes 5 seconds to complete. There is a limit to how many units can exist. For Bitcoin, it is 21 million units. Easily verify the transfer of the funds. As it uses the blockchain technology, it can easily verify the transfer of the funds. Operating independent of the bank, as it is decentralized, we have already discussed. Also, if new unit to be added after certain conditions are met. This we will discuss later. So how cryptocurrency works? Cryptocurrency works on blockchain technology. Blockchain technology is a set of blocks that record information like who made the transaction to whom. The amount of data in the form of digital ledger. Digital ledger is nothing but the amount of digital data that is stored in the blocks that is distributed across the entire network, meaning they are replicated and stored on each node. Node means on every computer across the entire blockchain network, and making it more secure and impossible to hack or change or cheat the system. Then it is verified and validated by every node to process with process of making the transactions. So what is blockchain? Blockchain is a digital ledger that stores transaction details. These records are stored in container called as blocks. These blocks are linked to each other and are secured by cryptography. So the features of blockchains are it is available for anyone to access. Data can be added but cannot be altered. To add data, mathematical puzzles has to be solved. Solution has to be approved by everyone in the network. And there is no central authority has control over the information. There are four major features that makes it special. That is, first is public distributed ledger, second is hash encryption, third one is proof of work, and fourth one is mining. So coming to the public distributed ledger, it is a collection of digital data which is shared, synchronized, and replicated across the world, across multiple sites, countries, and institutions. So consider a blockchain, for example, consider a blockchain that can be accessed by anyone in the network around the world. Now, but someone decides to alter this data. The data has been altered, but the data in one of the block has changed. Now, since everybody has a copy of the ledger, the alteration can be found and the data tampering is prevented. This is how no one can change the data from the blocks. Then they uses the hash encryption. So a blockchain uses cryptography to ensure the block and kept secure from unauthorized access and alteration. Blockchain uses SHA-256 for encryption. To validate blockchain also makes use of a digital signature. Each user has their own private and public key. The public key is used to uniquely identify the user. The private key gives the users access to everything in the account. Now, what happens in the sender's corner and what happens in the receiver's corner is given here. So the sender's message is passed to the hash function. Then we get the hash value. That hash value is passed through the signature algorithm with the private key. Then we get the signature, digital signature. Then we get the digital signature. Now that digital signature plus the message plus public key has been transmitted over the uh, over the world, over the world, and those who know the public key, they and what happens as the receiver corner is the message is passed through a cryptographical function to get a hash function, and to verify the authenticity, the hash value is compared with the hash output obtained by passing the digital signature with the public key through a verification process. This how it works in the sender's corner and the receiver's corner. The main is here the hash function, which gives us the hash value and also the digital signature. So hash encryption. So as there is block in the blockchains which uses SH256 to secure the data, every block in the blockchain has 4 fields. First is previous hash, second one is transaction details, third one is nonce, fourth one is hash address. So in the previous hash, this field is used to store the hash value. This field is used to store the hash value of the previous block of the blockchain. Then in the transaction details, a blockchain details of a block contains the details of several transactions. These details are passed in this field. So the nonce is nothing but a nonce value is a random value which is obtained by the solving the mathematical puzzle. Then the hash address. The hash address is a unique identification of the block. It has 64 characters that has both letters and the digits, and it is obtained by using the SHA-256 algorithm. Then the previous hash, transaction details, and the nonce are passed through a hashing function to produce the hash address of a particular block. Proof of work. Proof of work is a competition among the people around the world who wants to add a block to the blockchain. Finding this nonce value is a mathematical puzzle that miners need to solve. It is a process of finding an appropriate nonce that helps to generate a hash value that satisfies certain predefined conditions. Conditions like first one who solved that puzzle is been rewarded, and that the miner who get the answer of that puzzle first spread the word about finding the nonce value. Then the other miners also claim that it is also very easy to identify. That is, first they need to check if the output hash value falls within the target limit. That if it is greater than the target limit, then it has been rejected. Whereas if it is smaller than the target limit, then it has been accepted. Like the miner would like a miner would be able to find a nonce value while using a lot of time, money, and resources. Then the miner spreads the word about finding the value. Other miners attempt to validate the claim, and if verified, the miner is rewarded. This is what the process is. So the mining is a process of miner being rewarded for being the first one to find the nonce. This is by extraction adds the block to the blockchain. The miner is rewarded with 12.5 bitcoins or other forms of compensation. Mining ensures that there is a limit to how much Bitcoin can exist in the market. Mining is the only way new Bitcoins can be added. So as cryptocurrency is based on 2 things, that is, first is blockchain and second one is cryptography. So cryptography is a method of using encryption and decryption to secure communication in the presence of third parties with ill intent. So cryptocurrencies use cryptography for a few things like to securing transactions, regulating the creation of additional cryptocurrencies, and to confirm and maintain a record of assets transfer. To accomplish all these things, hash function is the one which is used, then the symmetric and the asymmetric encryption. In the symmetric encryption is also known as secret key encryption. Here we rely on only a single key. That is, to encrypt or decrypt the data, we use a single key. But there is some risk while sending it over insecure connections. That is, like, just imagine you want to share your front door key with a friend by hiding it under your doormat. So your friend has now access to your house. But there is also a chance a stranger could find the key and enter without your permission. So this is what symmetric key encryption is. Moving to asymmetric encryption, it is a public key encryption. which uses the pair of keys, that is public key and a private key. The public key that can be exchanged with anybody over any network. These keys has the information on how to encrypt the data and anyone can use it. But there is also a private key. The private key is not shared and hold the information about how to decrypt the message. Uh, anyone will anyone with access to the public key can use it to encrypt a message, but only the private key holder can decrypt the message. It also works like a mailbox. Anyone can put a message into the deposit slot, but only the owner of the mailbox has the key to open it and read the message. The public key encryption is a foundation for most of the cryptocurrency transactions. And third one is the hash function. Hash functions are another way cryptography can secure information, but instead of using keys, it relies on algorithm to turn any data into a fixed length string of characters. Hash functions also differs from other forms of encryption because they only work one way, meaning you cannot turn a hash back into its original data. Hashes are essential to blockchain management because they can encrypt large quantities of information without compromising the original data. Having an organized way to structure data not only increases efficiency, but hashes can also act like a digital fingerprints for any data that's been encrypted. This can then be used to verify and secure against any unauthorized modification during the transport through networks. Any changes to the original data would result in the new hash, which would no longer match the original source and therefore would not be verifiable on the blockchain. So as of now, 18,465 total cryptocurrencies are available. However, not all cryptocurrencies are active or valuable. Discounting many dead cryptocurrencies, it leaves only 10,365 active cryptocurrencies. Some of the examples of cryptocurrencies are Bitcoin, Ethereum, and Litecoin. So Bitcoin was founded in 2009. Bitcoin was the first cryptocurrency and is still the most commonly traded. The currency was developed by Satoshi Nakamoto, whereas Ethereum was developed in 2015. Ethereum is a blockchain platform with its own cryptocurrency called as Ether. It is the most popular cryptocurrency after Bitcoin. Whereas Litecoin, this currency is most similar to Bitcoin, but has moved more quickly to develop new innovations, including faster payments and processes to allow for more transactions. So I'm going to discuss two major cryptocurrencies among the many in the market. I'm going to compare it. First one is Bitcoin and second one is Ethereum. So Bitcoin is a form of digital currency and is decentralized without a central bank, whereas Ether is a currency that accepted in the Ethereum network. It uses Bitcoin uses blockchain to perform transactions, whereas Ethereum also uses blockchain technology to create an open source platform to build and deploy decentralized applications. Similarity between Bitcoin and Ether are they are biggest and more valuable cryptocurrencies. Both of them uses blockchain and mining currency using proof of work, which we have already discussed. So difference between Bitcoin and Ether is Bitcoin is used to send money to someone, whereas Ether is used as a currency in Ethereum network. In transactions are manual in Bitcoin, whereas transactions are manual and automatic in Ether. For Bitcoin, it takes 10 minutes to perform the transactions, whereas it takes only 20 seconds to finish the transactions in the Ether. Limit to the Bitcoin is 21 millions, whereas Ether, it cannot exceed 100 millions. Bitcoin uses SH256 algorithm, whereas Ethereum uses Ethash algorithm. One Bitcoin is equal to 30,79,841 Indian rupees, whereas one Ethereum is equal to 2,28,818 Indian rupees. So how to use cryptocurrency? Cryptocurrency functions a lot like traditional currencies in the sense you can make purchase and treat it as an investment. Purchases, you can use cryptocurrencies to purchase goods online as well as hire people to perform services. Cryptocurrency exchanges can be made for a fiat currency or a national currency such as USD and can be traded for a different digital currencies. Or you can invest You can also you can also invest in the cryptocurrencies by purchasing a given amount at one value and selling it when the value increases. Cryptocurrency values are subjected to volatility. The total value of the cryptocurrency or the market cap can rise and fall quite quickly. So, should you invest in cryptocurrency or not? There are many advantages to dealing in cryptocurrencies and a fair share of disadvantages as well. Here are the top 3 reasons that works in favor of and against cryptocurrencies. So the Nobel Prize winners like in the field of economics, Warren Buffett, Paul Krugman, and Richards, they feel cryptocurrency as they feel cryptocurrency is not it cannot be used in the day-to-day life. Whereas Bill Gates, Al Gore, they feel cryptocurrency is a good way to do the transactions in the businesses. So it all depends on an individual choice. They want to make investment in the cryptocurrency or not. So the advantages, I will start with the advantages. They are private and secure. The blockchain technology that fuels cryptocurrency ensures its anonymity. It also assures high level of security through cryptography, which we discussed before. They are decentralized, immutable, and transparent. The entire system functions on shared ownership, where data is available to all the permission members and is a tamper-proof. They are a hedge against inflammation. That is, cryptocurrency makes for a great investment in times of inflammation. For example, investors often compare cryptocurrency to gold. One of the reasons behind this is that just like gold, they are in the limited supply. So there comes the disadvantage as well, like they are not widely understood. They are a relative new compact, and the long-term sustainability of cryptocurrency remains to be seen. They are prone to high risk. That is, cryptocurrency bring in as many rewards as risks. Their high volatility and spectrality naturally makes them prone to sharp downward spirals. Investing in cryptocurrency can be risky for many reasons. The reasons like a major deterrent could be the fact that digital currency seems to have no inherent or underlying value. There is a supply demand type of equation that is used to determine the value of cryptos like bitcoins. Plus, it is easy to see how simple speculations over the internet can result in a substantial rise or loss of the value of these coins. Also, the fact that cryptocurrencies are banned or the usage restricted in lot of countries plays out as a significant risk. Their legality is debatable in countries like India. Also, the scalability is the problem. This is a complex issue which has more to do with the technology side of the blockchains. Simply, the sluggish nature of the blockchain makes it prone to transactional delays. This has a tendency to make crypto payments inefficient when compared to the modern day electronic payment techniques. So, thank you.
Yeah, very good. Any questions? Yeah, so subject the content is little more, but
Hello, sir.
yeah. No. Talk is good, but the content is so many things are so. Is it everyone clear or not clear? Yeah, any explanation at any point of time? Okay, just yeah, go ahead.
So last time Achala started with elliptic cryptography. So let us just quickly revise that. So basically what we are doing is, we want to use elliptic curves into the L-Gamma system. So for L-Gamma system, we need a group G, and then we take A, and there is some secret key N. So, and we compute A and B. And so this is sent by the recipient B. And then A chooses some integer K and she wants to send, or Alice wants to send the message W. So she'll send Y and Z and then we can compute W the following way. So we want to use this general crypto system for a group to a specific group, which is given by elliptic curves. So for that, we defined the addition on elliptic curves that turns it into an abelian group. And then we found out the algebraic expression for the point given by sum of 2 points. And then we also introduce the point at infinity, which acts as the identity. And then just use this particular group to L-camel system. And that is what elliptic curve cryptography is all about. So this much we did last time. So today I'm going to talk about the computational and practical aspects of elliptic curve cryptography. So now suppose we want to count the number of points on an elliptic curve over the finite field Fp. So there is no formula for E of Fp, number of points on an elliptic curve, even if you give A, B, and P. So we can't really give an exact number in terms of A, B, and P, but we can give some estimate. So for that, what we're going to do is, suppose I take some X. Okay. Just a second now. So suppose I take some X naught. I'm sorry, it's not working.
You can unshare and share maybe again.
Okay, it's not working. So
What about in the slides actually? Are you able to write on the slides? Okay, go ahead.
So now we want to count the number of points on an elliptic curve EFP. So for that, what we do is we just take some X naught in EFP and then evaluate f of X naught, which is just X naught cube plus AX naught plus B. So now we know that the set of solutions is given by X comma Y, where Y square is equal to X cube plus AX plus B. So in short, if this X naught cube plus AX naught plus B is a quadratic residue in FP, then the point X comma Y will be in the elliptic curve. So that is the basic idea. Now, if we assume that there is an equally likely chance of every element in FP coming up, then we know that exactly half of them are going to be quadratic residues. And each point will have 2 square roots except for 0. So any non-zero point will have 2 square roots. Any non-zero quadratic residue will have 2 square roots. So, and there are exactly p minus 1 by 2 of them. So this times 2, so plus or minus y. So this times 2 plus 1, which is given by 0, because 0 does not have 2 square roots. It only has 1 square root, 0. And this is the point at infinity. So this is our estimate for number of points on the elliptic curve, which is p plus 1. But we know that this is only an estimate. So this is not the exact value. But there's a theorem called Hess's theorem, so which gives us a bound for this error term. So this error term is number of points, which is the total number of points, and our estimate p plus 1. So the error is bounded by 2 root p and minus 2 root p. So yeah, so we have some sort of bound on the number of points on EFP. So later we will see that if this error is higher, then it's harder to break uh, the crypto system. So next, we want to look at embedding plain text into an elliptic curve. So for LGAML, what we did was, if we are given any, let's say, word in English, and we want to convert it into a number first, and that number should be such that it is less than p, because in the group FP cross rather, we know that so if our number is more than p, then it will be reduced to something modulo p, and then that message will no longer be recovered, because because our original message was something which was larger than p. So after we find a remainder on division by p, it will no longer be the same message. So we want a message such that its numerical equivalent is less than p. So now for LGAML, this was sufficient, because once we have a number which is less than p, then we can just straight away move on and then encrypt and decrypt it. But now for elliptic curves, we cannot do that, because for elliptic curves, we need a pair of points, and not just any pair of points. We need pair of points that satisfy the elliptic curve equation. So now suppose that we have already converted into an integer m, which is between 0 and some capital M. So we know that our computer will have some maximum bit size. So we cannot input more than that. Otherwise, it will create problems. So we know that this message m is bounded by 0 and some large integer m. Now, our machine is, let's say, not very reliable. So we assume that the probability of failing to convert a plain text is p, capital P. So there's a chance that for some message it's not possible to convert it to some point on the elliptic curve, and we just assume that this probability is p. Now what we do is we choose an integer k, which is larger than minus log p to the base 2. So why we are doing this will be clear later. So now after we choose this k, we choose a prime which is larger than m times k. So now once we do this, we can now create our elliptic curve over fp, where p is this prime given by p greater than m. And now our goal is to convert this small m into a point on the elliptic curve EFP. So here's how we are going to do this. So right, so now we have this m and we have this k. So we look at mk plus j. So where j runs from 1 to k. Now what we observe is this mk plus j, because of the bounds on p and m and k and so on, this mk plus j is always going to be less than p, where j runs from 1 to k. So we are guaranteed that this x bar belongs to fp. But now we don't know if f of x bar is a quadratic residue or not. So what we do is we just keep plugging in values of j until we get a quadratic residue. And suppose for some particular j, we find that, okay, this y square, this fx bar is actually some y bar square. Then we stop and then we just encode this message as x bar comma y bar. So now there could be a chance that this never gives us a quadratic residue. And what is the chance of that? So there is a probability of half, and there are k integers. So it is 1 by 2 power k. But we have chosen k in such a way that this will be less than p, where p was the probability of failing. So that is why this will give a large success rate. So now this is how we encode this x or small m into pm, which is x bar comma y bar. Now once we receive this x bar comma y bar, we would like to decode it into our original message m. So to do that, we just observe that is x bar minus 1 is between mk and mk plus k minus 1, because of the bound on j. And now then we do some manipulation, and then we find out that this quantity x bar minus 1 divided by k is in fact between m and m plus 1. And once we have trapped this between these two integers, we can just recover the message m as x bar minus 1 divided by k. So just take the greatest integer function of x bar minus 1 by k. and that will give us the original message back. Okay. So now let's take a look at the discrete log problem and elliptic curve discrete log problem. So this I'm sure we have already seen, but let me just quickly reiterate. So if we have a group G, then the discrete logarithm problem is the problem of finding the exponent x such that for G comma H, G power x should be equal to H. So if we are given G and H, we have to find some power such that G power x is equal to H. So note that such a power may not exist because this H may not lie in the cyclic group generated by G. But suppose we are given that it does lie here, then we want to find that x which gives us H. So this is the discrete log problem. And analogously, if we like let the group G be the elliptic curve EFP, then we can, and because this is an additive group, we just replace the power by multiple NP. So we want to find for points P and Q and N such that P times N times P is equal to Q. So if you observe, while sending the message, this N was sort of the secret key. So breaking into the elliptic curve crypto system is same as solving the elliptic curve discrete log problem. And in general, it is very hard to solve. So, right. So now we come to security of ECC. Why elliptic curve cryptography is so secure? So the point is that we already have the L-Gamma system, which works for any group in general. And the most common groups that are used are FP or FP cross rather. So why are we using the elliptic curve cryptography? So to break into the elliptic curve crypto system, we know that any adversary like E has to solve the ECDLP for EFP. Now, there are some algorithms that solve the discrete log problem in order of root P steps. So that is the complexity of that. So now later there were some advanced algorithms that could solve DLP in lesser time. So there is some algorithm that solves it in P power epsilon, where epsilon is some arbitrary positive number. So now what people did is we can modify the basic algorithms for DLP, and then those basic algorithms can also solve ECDLP in root P steps. So the point here is that ECEC is stronger because those advanced algorithms cannot be used for elliptic curve cryptography. So even those advanced algorithms cannot be applied for elliptic curves, but the basic ones can. But the basic ones are kind of slow, and they also need order of root P steps. So that is why elliptic curve discrete log problem is much harder than the DLP. So here we must be careful to say that in general it is harder, because what's really happening is, even if I fix some P, then I have to choose an A and N and then produce some B. If you remember, our A power N was equal to B. Now the thing is, breaking into this system also depends on how hard it is to break into the system, also depends on what kind of A and B I choose. So if A is a number with a very small order, then it is going to be easier. Or like there is some result that says that if this E of FP, which we found out, if it is exactly equal to P plus 1, then it's generally easier to solve the elliptic curve discrete log problem. So we have to be careful in saying that in general it is harder, because if we go into specific details, then it depends on what kind of prime we are choosing and what kind of A and B we are choosing. But if we assume that we are like avoiding all the cases where it is very easy to solve the problem, we can say that in the toughest case, ECDLP is much harder to solve than DLP. So that is the reason why elliptic curve cryptography is used, because the ECDLP is harder to solve, it is more secure than the usual L-Gamma system. So now suppose we want to find this on MATLAB. So here's how we do it on MATLAB. So for this, we just use some user-defined functions as well as inbuilt function. So this function will give us the next prime after this 10 power something. So this is our prime P. And now using LGAML with MATLAB is easy because we just have to find this A. We just have to set A, N, and B. And this power mod function does A power N. So this uses a very clever algorithm called double and add algorithm. So this writes the power N in terms of its binary expression. And then it's because we know that it's easier to add or add points rather than taking their power. So this algorithm capitalizes on that, and it keeps doubling and doubling, and then it gives the final result. Instead of brute force and using brute force and keep multiplying A to itself. So now remember that our message is encoded as W. So to do that, what we do is suppose, so this message is actually USMC. So now what we do is we convert every letter into some alphabet. And to do that, we just use the natural numeric order. So we say that A is mapped to 0, 0, B is mapped to 0, 1, C is mapped to 0, 2, and so on. So we notice that this is actually USMC because this 20 corresponds to U, this corresponds to S, this corresponds to M, and this corresponds to C. So this is the message that we want to send. And now Alice has to choose some K. So this is the K that she's going to choose. And then again, like as we saw, we have to recover this W from Y and Z. And then from Y and Z, we just use the power mod function that helps us calculate this encoded message W. So here we see that after calculating this expression, we again get 201, 2018, 1202, which was the original message W. So now suppose we want to define elliptic curves with MATLAB, then we know that we need this C and D. So this our elliptic curve is going to be x cube plus cx plus d. So we just have to choose coefficients and a prime p. So here we have taken a small prime because just to create a curve, we don't need a large prime. We need it for the crypto system. So first we need to check that the discriminant is non-zero. Otherwise, this creates problems. So here we check that the discriminant is actually modulo p is actually 7. So it is non-zero, so we are good to go. So now to define the elliptic curve, we just set this equation x cube plus cx plus d, where c and d are this. And then there is a user-defined function e points, which will convert this elliptic curve into, convert this equation into a set of points along with the group addition. So here equation is this equation, and x is the parameter with which we are going to calculate x comma y. And p is of course the prime modulo which we are going to calculate. And what this INF means is that if instead of INF, if I just put 2, then it will only give me 2 points on the curve. And in general, if I say n, then it will give me n points. Like so for example, 3, 4, then it will give me 3 or 4 points. So once I give INF, it will calculate all the points on this curve and then express them as an array. So this is the set of points on the elliptic curve. But we know that there is one point which is missing here and which cannot be just given by addition, and which is the additive identity. So we are just going to add 0 here. And then after adding 0, our elliptic curve is complete. So this is all the set of points on the elliptic curve. And if you want to calculate the number of elliptic curves, there is a function called numel. So this will give us 18. So we can quickly check that if we put 19, then 19 minus p plus 1 is between 2 root 19 and minus 2 root 19. So we can quickly verify Hess's theorem here. Now to add two points, then we know that there is some algebraic formula for adding 2 points. So we can just encode it and then create a user-defined function, which is called addx. And then this is our point 2, 4 and 10, 16. And we know that in the algebraic formula, only the C is involved. The coefficient D is not involved in the sum of 2 points. So here is the user-defined function and its output is 14, 16. So what that means is when you add the point 2, 4 to 10, 16, we get the point 14, 16, which should be in the elliptic curve. And then you can see that 14, 16 is indeed on the elliptic curve. So here are just some more examples of adding 2 points, like 0, 5 added to itself gives you 4, 6. and 0,5 added to 0 gives you 0,5 again, which is what we expect. And 0,5 and 0,14 is 0, which means that 0,5 and 0,14 are inverses of each other. So there is something really interesting about this elliptic curve. So here I am storing 0,5 as some element gen. And then when we run the loop over this gen and take all the powers of gen, we realize that it gives us all the points on the curve. So what it means is that this gen is actually a generator for this group. So this elliptic curve group that we have created is in fact a cyclic group, which is quite fascinating. So now suppose we want to do elliptic curve cryptography with magic. So now we have already defined the elliptic curve. So now of course for cryptography we need a very large prime. So we have chosen this to be our prime. And then we have taken the same coefficient C and D, and then modulo P, it is 976, which is of course non-zero modulo this large prime. So again, we set the equation as x cube plus cx plus d in the variable x, and then just find all the points. Or so here we can see that instead of I and F, we have one, sorry, not all the points. So we just need 1 point, right? Because we need A and B. That's the only thing that Alice is going to provide. No, not Alice, Bob. Bob is going to provide. So, right. So because 1 point is sufficient, we only calculate 1 point on the curve. And then we have to set some secret key n, which is set as this. And so we can see that both this A, B, and N and P are very large numbers. And then this B is calculated as this using this user-defined function. So again, we have to use the double and add algorithm to efficiently calculate this power. So then A power n is this number B, which is also on the elliptic curve. And then we know that Alice is going to set some K and some Y. And then we have to calculate KB. And this Y is actually AK. So now we have this Y and KB. Now, suppose this is a message that we want to send, which is rendezvous at noon. So now there is a problem here. So first thing is that we don't know what character we are going to give to spacebar, but that is a different issue. So now what we do is we just ignore the spacebar and then just we write it as a single one, because from context it will be clear where we have to break the sentence. But the bigger problem here is that if I convert this into a numerical equivalent, so I know that R is going to go to 17, E is going to 4, and N is going to 13, and so on. So ultimately, when I finish writing the numerical equivalent of this message, the number of digits in that message, in that number, is going to be more than the digits in P. So in other words, the numerical equivalent of this message is going to be greater than P. And we know that this should not be allowed because otherwise the message cannot be recovered and it will be lost. So what we do is we break this message into 2 parts, where the number of digits in each part will be less than P. So to do this, we are using the length split string, mesh blocks function, which will split the message into 2 parts. So this is one part and this is another part. Now, yeah. So now once we break it into this part, again, we need to make sure that this number is smaller than P. So here is a user-defined function that will check if this number is smaller than P. So here we can see that it is returning true, which means that both the components are less than P. And so we are good to go. Now we know, now it's easy to proceed. Now we know that we just have to recover W from the Z minus NY. And then, so now first we calculate this Z and then NY. And then we have to calculate Z minus NY, which is given by this function. So ultimately we come to this, but now we are not done yet. Now we have to convert this into word format again. So there is a user-defined function called toLetter. So it just breaks the message into 2 tuples. So 17, 0, 4, 1, 3, all of these are separate components. And then we convert them into letters and then concatenate them. So we get the original message, which was rendezvous at noon. So yeah, thank you. That's about it.
Okay, any questions? Yeah. So visual cryptography is it is a part of secret sharing. So it may not be part of your syllabus, but I want to give an application. In the syllabus, it is mentioned it's secret sharing. Okay, so it is but today I'm telling about visual cryptography. Okay, so when we think of cryptography, we think of complex computer algorithms, advanced um, computation that take best days or more to crack. But visual cryptography scheme, it is VCS, is different from other cryptographic schemes. What it is, what makes it different from other cryptography scheme is that secret image is reconstructed directly by the human visual system, and no computations are involved during the reconstruction, right? That you observed today. This scheme is so simple that even most ordinary computers can encrypt the message, and decryption can be done by anyone, anywhere, anytime without knowing anything about the cryptography. In addition, decryption technique is easy to learn. So moreover, one can implement it flawlessly. It even more remarkable that decryption is simple, elegant, and can be executed in almost no time. The best part of it is that it does not even require computer. Okay. So this is I think I shared the paper with you, but again I will share today. So this is actually concept by Nair and Shamir. Okay. So visual cryptography scheme is a set of P of n participants is a cryptographic paradigm in that enables secret image to split into n shadow images called shares, like that we just now I shared, right? So these are two shares, right? So individual shares, but if I put them, then they will get meaningful information, right? We saw that. So visual cryptography, so n participants will be there, and so we'll create n shadow images called shares, where each participant P receives one share, but certain only qualified subsets of participants can visually recover the secret image. Okay, with loss of some contrast. Okay, so you see that pi is visible, but it is not that much clear, right? But we can get the image, right? So that is the idea. So is it clear? This part is okay. Yeah, the collection of all qualified subsets is T qualified, and so it is a and forbidden. Those who cannot get it forbidden. So it is called access structure of the scheme, right? So for example, I have a lab, right? So laboratory, and there are my students are there. So but I want to give the key. So even without my presence, they can go and do work there. But I will not believe only one person. If at least 2 to 3 people go together, they can open it. Are you okay? Are you understanding the problem? Hello? Hello? Are you following?
Yes.
What is it I want to say? See, I have a laboratory, and my students, I want to allow my students to access the laboratory without my presence. But I will not believe in one person. So I'll make my system in such a way that at least 2, 3 people come, then only it will open. Or 2 people will come, then only it will open. Are you following that point?
Yes.
Yeah. Similarly, if so, for example, you know that the paper is distributed from the question paper. But instead of giving it to all the principals, what I will do, will give you the shares now. Just imagination. It is just my imagination. So we'll give share to the principals. At least 3 to 4 principals come together, then only paper will be revealed. Right. NCRT sending some paper, whoever, higher authority, CBSE, so sending paper to the all the centers. But instead, it only send the shares, right? Similarly, in legal systems, many places we can use it. Okay, but you better understand once you clear it. The key is chosen by a special participant D called a dealer. It is usually assumed D does not belongs to P. Okay, the dealer gives partial information called share or a shadow to each participant to share the secret key. The collection of subsets of participants that can be reconstruct the secret is usually monotone. Okay, okay, let us see an example. So the dealer is there. So dealer want to give shares to these people one by one, right? But these people are now not aware of what actual message is, but they only get share that does contain nothing, right? So now I'm telling about k comma n threshold scheme is a method where n pieces of information of the secret key called shares are distributed n participants so that secret key can be reconstructed from the knowledge of any k or more shares, and the secret key cannot be constructed from the knowledge of fewer than k shares. Is it okay?
Yes.
If k or more people come, then it is called k comma and threshold scheme. There qualified and all is not there. Any number, any number of people k, number of participants k or more, then they are qualified. It is less than qualified. Okay, this is another thing. Yeah. So this is called k comma and threshold scheme. Okay. So, but in reality, there are many situations in which it is desirable to have more flexible arrangement for reconstructing the given n participants. One may want designate certain authorized groups of participants who can use. That also possible. Okay. So that is called general secret sharing scheme. Yeah. Okay. So it is like you saw maybe that some movies, there is a treasure, right? The entire map is not there with everyone, right? So pieces will be there. They come together and they will get. This is like that. Single piece will not give any information. Okay. Yeah. Yes. Okay. So K comma and threshold scheme is actually defined like this. Okay, I'll come to this later if required. The simple version of visual secret sharing problem assume that messages consist of certain black and white pixels. Okay, you know that if I take an image, right, we take a picture, then it is actually pixels, right? So assume that we are taking black and white. That is possible. In computers, we can convert color photograph into black and white. Okay, still I can see the things. Secret is known. So without loss of generality, we are assuming that we are having image with black and white pixels. Okay, now what we will do, we will take a white pixel and we'll enlarge it. We make it a matrix. One pixel converted into some n cross n pixels. So some k cross k pixels. Similarly, black pixel also converted into k cross k pixels. Okay, that means we are enlarging the image, both width and height. Are you following? Each pixel is replaced by a matrix now, but again black and white pixels. Okay. Now suppose we want to distribute secret image as shares among the set of two participants in such a way that from a single share it is not possible to decode the secret image, but both the participants came together and superimpose their shares, it will be possible to decode the secret image. This is called 2 comma 2 visual threshold scheme. Okay, I will explain you that with one example. Okay, so I'll come to this because you'll get bored. So you will first understand here. So we have two pixels, right? White pixel and black pixel. So white pixel, I can make it like this. Okay. So these are two white pixels. Okay, or this or this. I'll take a coin, toss a coin, and then I will take it. Okay. So now, if you first, for example, if you superimpose these two first to what we'll get? Are you okay? This is the one
The
share.
same thing.
Same thing, right? Yeah. This is also same thing. But look at coming here, black pixel. Black pixel I converted into two shares like this. Two shares like this. So I will give this share to one person. I gave this share to one person. So individually they don't know, right? But if they superimpose, then I'll get a black. Yeah. So white pixel is so white pixel can be converted into shades like this. Black pixels converted into shades like this. Two shades now. It is only two shades. Okay. What I will do now, I'll take a white pixel and I'll toss a coin, and I'll take either this pair or this pair. So at this juncture, forget about the second pair. Let's concentrate on first pair. So I'm giving this to the first person and give this to the second person, right? So they do not understand. So now every pixel now, black pixel, and then again I'll give it as a white and black. Yeah. So they do not understand the picture now, because every white pixel as well as black pixel now become two pixels, both black and white. So they could not get the information. Okay. So now, but if you, so that is what, suppose we look at the two subpixels. The first share corresponds to a pixel P in the secret image. One of these two subpixels is black and other is white. Moreover, each of the two possibilities, that is black white and white black, equally likely to occur, independent of whether corresponding pixel is secret image is black or white, right? That just by looking the first share, it is not possible to predict whether the subpixels in the share corresponds to black or white in the original secret image. I hope it is clear to you. The same argument is applicable for the second share also, right? So yeah, so that is the way. Yeah. So is it clear now? Some questions? What is that we are doing? We are taking a white pixel. That white pixel we made into two shares, like first two shares, this share and this share, right? And I gave this to one person and I gave this to another person. Now I look at the next pixel. If it is again white, again I'll give this to the first person, this to the second person, or one of these. You can take either this or this, but for one pixel, you take these two shares. Both we need to take. You cannot take like this, okay? Then again there is a problem, right? You take these two shares or these two shares. It is up to you. But each white pixel also you can share. That's not change. That's not a problem. But let us concentrate that we are giving the first two shares. When white comes, black comes, we are giving the first two shares, right? Yeah. So now each pixel is shifted like this. Now they come together. Black is visible very much, but white becomes white and black. Now that is the problem here. Black becomes black. That is good, but white becomes black and white. So there is a little bit of contrast is there. Earlier white pixel now become white and black. So that's why there is some contrast, but image can be seen. That is what happening. Is it okay?
Yes, sir.
Everyone, other persons?
Yes, sir.
Yeah, good. So that is what I showed you with my transcripts, right? Okay. Yeah, okay. So now we consider the situation when two shares are superimposed. The pixel P is original image is black. Then after superimposition of the two shares, we get the two black subpixels in the superimposed image. Whereas P is white, then after superimposition of two shades, we get one white and one black subpixels in the superimposed image. Thus, we can say that the particular case, the restructured pixel as gray value 1 if P is black, and gray value of white is 1 by 2, not 1. Okay, so we can see that there will be a 50% loss of contrast in the reconstructed image, but should still be visible. We are actually losing some information, but still not a problem. So so how mathematically we can make it, right? So for example, you have a two visual cryptography, right? As explained mathematically. So we take two by two Boolean matrices S0 and S1. Yeah. So that I can convert like this, right? 0, 1, 0, 1. Are you following? 0, 1, 0, 1. Whereas black ke liye, I'll take 0, 1 and 1, 0. These are the two matrices called basis matrices for 2, 2 VTS. Yeah. where 1 stands for black pixel and 0 for the white pixel. So first we observe that 2 rows of S0 corresponds to white black, and white black and white black combinations as given in the first line of the third. Yeah. Similarly, 2 rows of S dash will corresponds to the white black, black white. Right? You understood that. Yeah. So now let the pixel be secret image. So we can write a program also. Original message black and white. So then you convert it into big 2 shares you can create and give it to the. It is a we do by using computers. The pixel P secret image block. Since P is black, we use S dash. Okay. The basis matrix correspond to the black pixel. So here. Yeah, so you superimpose still not a problem, but here I'm taking now each pixel is converted into 4 by 4. Earlier to 1 cross 2, you see that here it is 4 by 4. Each subpixel converted into 4 by 4 subpixels, 4 pixels actually. Okay, right. Yeah, so we give the first 2 rows of T dash to the first participant like that. Yeah, so this is one. So there is a parameter related to contrast and all. So there is another example. So this is another one. 2 comma n. In general, how do you do? Now we have a question. For example, n participants are there. How can I give, right? 2 comma n visual cryptography. Can you see here what is happening in this? Can you say something? Is it visible, my what I'm sharing?
Yes, sir.
Yeah, can you understand what is happening? And tell me.
So we can say that again 0 is the white pixel and 1 is the black pixel.
Mm-hmm.
And
Yes.
then if you superimpose the rows of S0, then all of them are just going to be the same.
Yeah, so if you superimpose two rows of S0, correct. Then the first one is black and all others are become white. Whereas the second one, S1,
Then the black and white will be superimposed to give you some gray.
yeah. So, but there are many whites are there. Are you following that?
Yes, sir.
Yeah, but here, what happens if 3 people come together? More and more, right?
Yes, sir.
So 2 people come, then they can see that white pixel, black pixel contrast is now so much contrast, because black pixel also so many white pixels are there, but still we can see. Will not, but 3 people come better, 4 people come much better. So more and more visibility will be there. Are you okay? Are you understand?
Yes, sir.
Yes.
Yeah, good. So this is the thing related to that. So just let me unshare and share a Wikipedia website. Right. Yeah. So in the Wikipedia also, you see that 2 shares they made it here. Share 1, share 2, they are superimposing. Wikipedia, are you able to see that?
Yes, sir.
Yeah. So each pixel we are converted into blocks of pixels. Okay. Yeah. So now the question coming to you. So that is 2 comma and visual cryptography scheme. So this is what I showed here, right? Yeah. Okay. One more. So if you want more, then you can also, there is a Douglas Stinson. You can go to his website. He also gave few more. Yeah. Yeah. Okay. Right. Okay. So these are this is related to the visual cryptography. So, but here I gave some details. So how much contrast is there and all. Okay. So it will be little boring to you. So these details, but you understand the main essence, right? When 2 comma n, 2 comma n you go, the matrices, right? 2 comma n you take. So then as n increases, contrast is very high. It's very problematic. Yeah, that is what explanation is given here. Yeah, okay. So actually, but how do you construct these matrices, right? Is there the only matrices? Is there any other way? So that is what polynomials, geometric configurations, block designs, Reed-Solomon codes, vector spaces, orthogonal arrays, Latin squares. So there are many techniques are there to construct these two matrices. Are you okay? Yeah. So the very big area again, secret sharing itself, right? In the next class, I will tell you actual secret sharing. That is also very simple. So that is by polynomial method. That I will explain you. That is in your syllabus, Washington book me. So I'll collect material from there because I already introduced actually. It also takes just 10 to 20 minutes class only. The reason is I already introduced Van der Monde matrix because that it becomes very easy. Yeah. So, but I'll tell in the next class that part. Yeah. So I'll stop. So any questions you can ask so that I can, I'm showing slides little faster because main content I mentioned, informed you. So why to read actually, right? Yeah. So that's the reason. Yeah. But so general secret sharing scheme is that will make some people are authorized, some are not. That is little complicated. Yeah. But that can be done. We'll give shares in such a way that those people come, then they can. Other people will not get it. Right.